All right, we are still working on our first standard. This is our third video for the first standard of chapter 3. So now we're going to move on and take a look at introducing absolute value inequalities. So we really have to understand the idea of the absolute value equation to be successful at understanding the absolute value inequalities. So make sure that you got your work titled, and we're going to go ahead and get started on these. All right, here we go. I want to remind you of the definition of absolute value in general. I'm going to start by drawing our number line, which is how we actually began the definition of the derivative in the first, definition of absolute value in the first video. And that is that we talked about it being the distance away from zero. So I could have two values that allow me to be 3 spaces away from zero. So this right here is exactly the distance of 3. So that is a distance equal to 3. But what if we were talking about a distance that was less than 3? So how can I have a distance that is less than 3? Well, that one means it would have to be closer to 0 than 3 spaces away. So we end up with this space in between. That is a distance that's smaller than 3, less than 3. Now if we talked about a distance being greater than 3, a distance that is greater than 3, and that distance would have to be farther away from 3 than exactly 3 spaces. So those would be out here. This would be our distance greater than 3. Keep this in mind as we go ahead and solve this, because this should connect back to one of our earlier standards with inequalities. If we can draw a conclusion, if I have an absolute value that is less than a constant, let's just put a number, less than a number, then I should be working with an intersection. I should be working with an AND statement. If we have an absolute value of any quantity that is greater than a number, we should have a union or an OR statement. And we will be using interval notation to express these. Let's go ahead and give some of these a try. We're going to work through 4 examples here. Here's our first example. 2x plus 1 inside the absolute value is less than 7. This says my distance is less than 7. I am closer to 0 than 7 spaces away. Okay, so we still need to think about the left and the right. But we need to say that if I am going to be less than 7 to the left, so on my number line, if I'm thinking about 7, and I'm thinking about negative 7, if I'm at 0, then I need to be greater than, take that back, I need to be less than 7, and over here we need to be greater than negative 7. So let's think about that. If I have 0, my distance from 0 is going to be 7. And I wanted to represent a distance that's smaller. That would be recognized by saying that x must be greater than negative 7 and x must be less than 7. Well, I'm not talking about x, I'm talking about 2x plus 1. So we will write this using an AND statement as 2x plus 1 is greater than negative 7 and 2x plus 1 is less than positive 7. This gives me that intersection of these values. Let's proceed and solve this. I'm going to subtract 1 from both sides on this part. I have 2x is greater than negative 8, making x greater than negative 4. I'm going to keep the word AND. Over here, I'm going to subtract 1, giving me 2x is less than 6, and divide by 2, giving me x is less than 3. So my values are that I have between negative 4 and 7. This is a between statement. You may write it as if I ask you for in one notation, this is fine. But if we wanted interval notation, we would be talking about going from -4 to +3. To write it in the between statement, I could say -4 is less than x is less than 3. So it depends on the interval notation or if I want set notation for your answer. We can also represent this on a number line. From -4 to +3, open circles on both and shading in the middle. If you notice that the distance there is 7. Let's go ahead to try example number 2. Here I'm going to tell you that the absolute value of 5x minus 2 is greater than or equal to 8. So on my number line, just in my head, I'm thinking, all right, I've got -8 and +8, and I need to be greater than that, or equal to, of course. So I need to be farther away. Well, in order to be farther away, I need to be less than or equal to -8 or greater than or equal to +8. But I'm not using just a plain old x. I'm using this quantity of 5x minus 2. So we will write 5x minus 2 is less than or equal to -8, or 5x minus 2 is greater than or equal to +8. Now I can go ahead and solve them. I add 2 and I get 5x is less than or equal to -6, and x is less than or equal to -6/5. Or add 2 and you get 5x is greater than or equal to 10. Divide by 5 and you get x is greater than or equal to 2. So this is my statement using inequalities. If I wanted to write this in an interval notation, it would require 2 intervals. I would say from -infinity up to -6/5 inclusive, and it is a union from +2 to +infinity. On my number line, I would plot these two values, -6/5 and +2, and I would go ahead and put solid circles on both of those and shade outward. And there you go. Okay, let's try one more example here. I've got the absolute value of 2 minus 7x minus 1 is greater than 4. Before I can work with this, I'm going to have to take care of everything on the outside of the absolute value, which means I have to add 1 to both sides, leaving me with the absolute value of 2 minus 7x is greater than 5. Now I can consider that I have to have this quantity to be greater than 5, or this quantity has to be less than -5. And that's sending me out in both directions because I want it to be a further distance. I want it to be further away from 0. If you want to get further away from 0, you have to be less than this number. If you want to be further away from 0, you have to be greater than this number. Okay, so we'll solve both of those by subtracting 2 from this side, giving me -7. When I divide by -7, I actually have to switch my symbol. Don't forget, that gives me x is greater than 1. Or, over here when we subtract 2, we get -7 is greater than 3. When we divide by -7, we get x is less than -3/7. So these are in the wrong order in my head, so I would prefer to switch them. It's not necessary, but I would prefer to switch them. That way when I put them on my number line or I draw a conclusion, it's easier for me to visualize. So I would make it x is less than -3/7 or x is greater than 1. This on a number line would have my 3/7 with an open circle, my 1 with an open circle, and shading towards the infinities. As an interval notation, we go from -infinity to -3/7 exclusive, union from 1 to +infinity exclusive. So it just depends on what you're being asked for. Let's go ahead and look at the last example. Here we're going to be considering some special situations. Let's suppose I give you some sort of quantity, inside of absolute value, and I say that this absolute value has to be greater than or equal to -10. Well, What do you think about that? I'm saying the distance has to be greater than a negative number. The distance has to be greater than a negative number. I'm hoping you're thinking this. Well, no kidding, it has to be greater than a negative number because it has to be positive or equal to 0. So it doesn't matter what I put in here because my values will always be greater than negative 10. So anytime you have a quantity that is greater than or equal to a negative number, we know that it is all solutions. Another situation, what if I have a quantity that I'm taking the absolute value of, and I say that it has to be less than or equal to a negative number? Negative 3, for example. I'm saying this quantity, when you take the absolute value, must be less than a negative. Hopefully you're going, huh? That's impossible. It doesn't work that way. And you're right, there are no solutions. All right, go ahead and consider all of the situations that we worked on here. Review anything from this video if you need to. Make some notes, ask me questions, try the entrance slip, and we'll work together in class.